rules of inference, also known as inference rules, are a logical form or guide consisting of premises or hypothesis and draws a conclusion. So basically, what is the idea of this rules of inference? We start with some statements. Let's say statements are like this: statement 1, statement 2, statement 3, up to let's say statement n. And then we talk about some conclusion statement, let's say C. And then basically we are assuming that all of these statements are true simultaneously. So that means we are assuming S1 and S2 and S3 up to Sn. And then we are saying that if these statements are true, then statement C is also true. So that means we are interested in identifying the truth value of this particular implication, right? S1 and S2 and S3 up to Sn implies C, whether it's tautology or not, right? And depending upon that, we will say whether the given arguments are valid or not. So for that, we need to understand what is valid argument. So an argument is a sequence of statements that end with a conclusion. So basically, we are going to start with this set of hypotheses. In between, we are going to use this guide, which is nothing but rules of inference. And finally, we'll come to a conclusion. And this conclusion may be it is matching with the given conclusion C, or it may not, right? So it depends upon the context and how we simplify the given set of statements. And we'll say the argument is valid if conclusion or the final statement follows from the truth of the preceding statements, right? So if we can successfully derive the conclusion, then we'll say that our argument is valid, right? And in other words, if all the premises are true, then the conclusion is true. We are trying to verify this. Okay. So now, before we formally see this rules of inference, let's try to relate this with our real world. So what we are going to do? We are going to consider several examples, and for each example, I have tried to follow this particular template. So what is the template here? The template is some set of statements are given to us, okay, and then from this set of statements, one conclusion is written. For example, here, this is my statement 1, this is my statement 2, and finally I am concluding this. So now we need to verify whether this particular proposition S1 and S2, so that means S1 is true, S2 is true. Given S1 and S2 is true, what can you say about truth value of conclusion, right? So let's read about this statements first, and let's read them first, and then we will verify, we will check whether this particular conclusion is valid or not. So the first statement is saying, if it is raining, then I will make coffee. The second statement is saying, it is raining actually. And the third statement, which is actually the conclusion is saying, therefore I will make coffee. So what do you think about this? Do you think it's correct or wrong? Any answers?
It's correct.
Okay, it seems correct, but if we try to write this in terms of propositional logic, then how should I write it down? I need to take some propositional variables. So which variable should I consider?
Sir, let P be it is raining and Q be I will make coffee.
Okay, so let's say P, this segment, it is raining. This is P. Okay, so raining is, let's say, P. Then coffee, right? I will make coffee. This particular statement is corresponding to, let's say, Q. Then the first statement is saying, if it is raining, then I will make coffee. So the equivalent representation will be P implies Q, right? And second statement is saying, it is raining actually, right? So that means we are saying the statement P is actually true, right? So if these two things are given to you, then we are concluding that I will make coffee, and coffee is corresponding to Q. So that means I am saying this. Okay, fine. So now let's analyze the second one. So basically what we have shown here, we have basically shown that if P implies Q is correct, right, and P is correct, then Q is correct, right? So we are basically trying to evaluate this particular compound proposition. Okay. So now let's consider example number 2. Again, we can reuse the same terminology, right? It is raining, let's say P. I will make coffee, let's say Q. And then again, one more statement is that I do not make coffee, that is nothing but we can say negation Q. And therefore it is not raining, which is nothing but negation P. So again, what I can do, I can say that this is my statement 1, this is my statement 2, and this is my conclusion. And now we need to identify whether the conclusion is valid or not. So if it is raining, then I will make coffee. So this is similar to P implies Q. It is actually P implies Q, can I say?
Yes, sir.
Right. And we know that P implies Q is equivalent to negation Q implies negation P. Right? The second statement is saying, so this is nothing but a representation for statement 1. For statement 2, what we can say, I do not make coffee. So that means negation Q is given to you. And final conclusion which we are giving is it is not raining. So it is not raining, it's equivalent to negation P. So if I consider example number 1, and in example number 1, if I replace P with negation Q and Q with negation P, then can I say both of these are equivalent? This 1 and 2. The template is similar, right?
Yes, sir.
So here again, we are using this particular notion of equivalence, right? P implies Q is equivalent to negation Q implies negation P. Okay, fine. The next one is, if it is raining, then I will make coffee. This is my statement 1. If I make coffee, then I will watch TV. This is my statement 2. And my conclusion is, therefore, if it rains, then I will watch TV. So here I need to add one more propositional variable, not just P and Q. I have one more variable R, where R is corresponding to TV. Right? If R is true, that means I will watch TV. If R is false, then I won't watch TV. Can you give me the equivalent representation in terms of propositional variables first?
Sir, first statement is P implies Q.
P implies Q. Good. Second statement,
Q implies R.
Q implies R, and
And third is
conclusion
P
is
implies R. P implies R.
P implies R. Okay. So what do you think?
So it's valid.
But how did you verify? It's not straightforward, right? When can we say that this particular conclusion is valid? So let's again revisit. Basically, what we are doing here, we are saying S1 and S2 and S3 up to Sn. This implies C. So here we are assuming all of these are true together. So that means we are considering this particular case true. We don't know about truth value of conclusion, that we need to find out. And overall implication, what can we say? If conclusion is true, then we will say that overall implication is true, and hence we will say that our arguments are valid, the conclusion is valid. If conclusion is false, then we are referring to this particular case, second row of P implies Q. And what will happen here? Can anyone tell me? The overall implication will be true or false?
False.
False. And we will say the arguments are not valid. right? So this is the idea. We are referring to these two rows. So basically there are four rows if you remember, FT and FF, but we are not considering these cases because statements are given to you. And the assumption is this set of scenarios, this set of constraints are real, right? They are happening together. So, and they are true, that means. So therefore we are considering only row 1 and row 2, right? So this is given S1, S2, S3 up to Sn. Then some conclusion is given. We need to identify its truth value, and depending upon its truth value, whatever truth value we will get for conclusion, the same truth value will be for our overall implication also, right? Do you agree with this? So now, formally, what we need to show, if we need to show that for with respect to example 3, our answer is correct. So I am talking about this particular box as of now. Now don't focus on other boxes. What we need to do formally if we want to identify validity of this particular statements S1, S2 and C. Can anyone tell me?
Sir, make a truth table.
Prove, so we can prove that their intersection is P implies R. I mean,
Sir,
conjunction.
But which compound proposition do I need to consider for making truth table or verification? Do I need
Sir,
to
P
verify P?
implies Q intersection, Q implies R.
It's not intersection, conjunction, right?
Conjunction. Yes, yes, yes.
yes.
P implies Q, conjunction,
Conjunction.
Q implies R, then
And P implies, this will be equivalent to P implies R.
equivalent to or implies? Both are different. Are
Implies,
we
sir.
considering this? Are we considering this or are we considering this?
Sir, implies.
Second one.
Right? Okay, fine. Why not first one?
So, because conclusion doesn't need to imply the statements.
As of now, this answer is correct. We need to verify this. But how will you verify this? How will you identify whether this one is correct or not? This validity of this compound proposition, how will you verify? Someone was saying truth table. So can you explain which compound proposition you will check in your truth table and which value that particular compound proposition must obtain if the given arguments are correct and conclusion is true? P implies Q and Q implies R implies PA implies R. Now what you are suggesting?
So this should be a tautology.
But how will you verify this is
Sir,
whether this is
taking the 8 combinations of PQR.
okay? So basically, you are saying truth table. Using truth table, we can verify this. This is one answer.
Sir,
Okay.
we can also
Yes.
use like logic, propositional logic.
Okay. So that means nothing but simplification, correct? And we have
Yes, sir.
seen several
Using
simplification rules, including we know what is equivalent of P implies Q, what is equivalent of Q implies R. Then we know the Morgan's law, we know distributive law, right, and so on. Anything else? Okay, fine. So we'll talk about this soon, but this two approaches are there in order to uh, verify whether this particular compound proposition is correct or not. So you can actually take those 8 combinations and then you can verify that actually this conclusion is correct, right? Okay. Again, we will revisit this soon. Let's consider the remaining boxes. How about this one? I will make coffee. Therefore, I will make coffee or I will watch TV. What do you think? So focus on this box only. Can anyone give me equivalent representation
Sir,
first?
sir, P and P or Q.
So this is my statement S1 and this is my conclusion. That's it. So what you are suggesting?
P implies P or Q.
P implies P or Q.
Or Q.
This is my P. Okay. And my conclusion is P or Q, right? No, P was corresponding to reigning, I guess. So we must use Q here, right? P was corresponding to reigning, Q is corresponding to coffee, right? So we must write here Q and Q or R, not this, right? So that means now again, which compound proposition we must consider if we want to
Q
verify?
implies Q or R.
And what do you think?
Invalid, sir.
Always true.
How many of you
Always
think
true.
that it's tautology?
Sir, me.
The tautology है.
Yes, sir.
ये सर टोटोलॉजी है
Yes, sir.
सर नॉट की यूनियन क्यों आ जा रहा है सर मतलब
Not Q?
नॉट क्यों डिसजंक्शन क्यों आ जा रहा है सर
Not Q,
और
disjunction Q. It is always true, right?
Yes, sir.
So someone is saying after simplification, he is getting this not Q or Q. So not Q or Q is always true, right? Because if Q is true, then it's anyway true. If Q is false, then negation Q is true. So therefore it's true, right? So in all cases, it's tautology, right? Okay, fine, good. Now we'll talk about this one. Okay, so let me put it somewhere here. Not straightforward now, so you need to think slightly more. Okay, so it is raining or I will make coffee. This is my statement 1. It is not raining or I will watch TV. This is my statement 2. And the conclusion is like this. Therefore, I will make coffee or I will watch TV. So can anyone tell me the equivalent representation first?
Sir, P or Q.
P or Q.
P or Q.
Not P or R. Sir, Q or R.
And now what I need to check?
Sir, P or Q in conjunction. Not P or R implies Q or R.
And what do you think? Okay, think about it. We'll discuss soon. But this is there. Okay. And we'll take what remaining 2 examples now. Okay, so next one is this. I will make coffee and I will watch TV. So we will revisit this. Don't worry. Okay. I will make coffee and I will watch TV. Okay. So can anyone tell me the equivalent representation? This is my statement 1, and then fine, I have conclusion directly. So what is statement 1?
Q and R. Q and
Q
R.
and R. And what I am concluding?
Q.
Q. And which proposition I need to consider?
Q and R implies Q.
And what do you think?
Sir, always valid.
Always true.
Okay, so
the
I
tautology
guess, we are left with only this one case. All others are completed, and then we'll again revisit all these rules, and we'll understand in depth how they are working and what are they called. But let's complete this last one. So I will make coffee or I will watch TV. I will not make coffee. Therefore, I will watch TV. Okay. So this is my statement 1. This is my statement 2. This is my conclusion. So can you tell me the equivalent versions?
Sir, Q or R.
Q or R?
Not Q.
Not Q.
And conclusion is R.
And what do you think about this compound proposition Q and R and negation Q? This will imply R, and we need to verify this.
Always true.
Okay, fine. So now, before we go further, I guess let me consider this particular compound proposition. It's not straightforward, right? And this one is remaining. We need to verify whether this particular compound proposition is tautology or not. So you have already suggested 2 things. First one is truth table, right? It will take some 8 rows, right? Second one is you are saying we can also apply rules of simplification. This will take,
Sir,
right?
here we
So,
can take PJ.
okay, so let me complete this, then you can give any other method if you have. So here you require some amount of smartness and intelligently apply the rules which we have for the simplifications, and then maybe we can reach to the conclusion, right? So definitely we can reach to the conclusion. Whether it's valid or invalid, it's a different thing, but we can do this. Any other method apart from this?
Yes, sir. I mean,
Uh,
here it is applicable.
Tell me.
Sir, like, sir, it's an approach. Like, let's assume that either one of Q or R is true. So then our conclusion will be true. So this will also be true.
Okay, so your the direction is correct,
Approach.
but all you need to do is you need to slightly modify your arguments. So basically, what he is suggesting, and based on his suggestion, what we can have is we need to just show that this particular case is not possible. Do you
Yes,
agree
sir.
that if we can show that this case is not possible, then we are done?
Yes, sir.
Yes, sir.
So let's try to apply this particular method here, method number 3, where we are just trying to showcase that this case is not possible and all other cases anyway implication will be true, right? So if this is the case, then I must assign false to Q as well as false to R. Do you agree?
Yes, sir.
So I must put false here. I must put false here. Okay. Now, if I have just remaining the last variable P. So let me consider one case where value of P is 2. If I take value of P true, then value of negation P will become false. And now if I consider this second compound proposition, like a subcompound proposition, then it's false disjunction false. So this is always false, and false if if the truth value is false and then you are taking conjunction with any other proposition, then your final answer will be false, right? So this case is not possible. So this is not this assignment won't work. So we didn't have choices for Q and R. Q and R we mandatorily need to put F only, false only, because then only this will work. Then only we will get false here. But here we need to show that two cases possible. If it's not, then that means this case is impossible. This entire case where you are assigning true to your hypothesis and F to your conclusion is impossible. That means all the cases, only the remaining cases are possible, and that means your entire implication is always true. That is ideal. So now P is equal to true won't work. So let's try with P is equal to false. So if P is equal to false, then this will become true, but as you can see, the first subcompound proposition will become false. And if you have false conjunction with any other compound proposition, your final answer will remain false. So that means we have just shown that this case is never possible. So that means the entire compound proposition is always true. So therefore we can say it's tautology. Therefore we can say, now you need to tell me this was corresponding to which example? This one, right? So that means we can say that this conclusion is valid. Do you understand this?
Yes, sir.
Okay, fine. So now let's quickly learn about these rules, what they are called, right, one by one. So the first rule is called rule of addition. What is rule of addition? Rule of addition is saying if P is given to you, then you can take disjunction with any other propositional variable, let's say Q, and still your overall implication will be always tautology. So this is your tautology. This is name of the rule. Right? So my name of the rule is addition, and tautology is P implies P or Q. So can you quickly verify why it is tautology? How will you argue?
Sir, one condition only false when has to true and second is false. वो तो possible नहीं.
So both of these must be false, then P must be false. So TF case is not possible, hence this is tautology. Okay. And can you tell me the relevant example from this? ये हमने कहाँ पे देखा था? Sorry. So यहाँ से हमने start किया था.
I will make coffee वाला sir, second or third था maybe. Yes sir.
Right. This one was there. I will make coffee. Therefore, I will make coffee or I will watch TV. So can you generalize this? Can I write like this? If Q is there, then I can say Q or R dash or R double dash, right? Will it work?
Yes, sir. Yes, sir.
Okay. So if one condition is given to you and if that particular condition is true, then you can add as many conditions you want to that particular condition. Still your new compound proposition will be always true because the first condition is true and you are just taking disjunctions. Okay, so that is the idea. Okay, fine. Let's move forward. The next rule is called simplification. Okay, so why it is called addition?
Sir,
Yes.
सर मतलब आफ्टर इम्प्लीकेशन सर पी डिसजंक्शन क्यू है सर, उसके बाद क्यू आर भी हो सकता है डिसजंक्शन मतलब एडिशन.
Right. Okay. So even Q is addition here, right? As you can see, given condition is related to P only, but you are adding Q, so you can also add R. That is the extension which I am talking about. But even in this particular case, you have added just one more extra condition, which is nothing but Q, right? So therefore, it's called addition. How about the second one? P and Q, and from this we'll conclude P is 2. So that means the equivalent compound proposition is like this. P and Q implies P. This must be tautology. Can anyone prove this?
सर नॉट पी डिसजंक्शन पी आ रहा है सर.
Not P disjunction P, which is true always. That's why. Or otherwise, we can also argue like this. If we take false here, then basically it's corresponding to false and something. Then false and something cannot become true. So that means TF case is not possible. So therefore, it's always going to be true. Right? And why it is called simplification? Any idea?
Because it is simply after simplification sir not p disjunction p आ रहा है sir.
So this is not P disjunction P is equivalent to true. So therefore it's tautology. That is fine. But I'm asking about the name. Why it is called simplification? Basically we are removing something. वहाँ पे हम कुछ ऐड कर रहे थे. यहाँ पे हम सिंप्लीफाई कर रहे हैं. ये जो एक्स्ट्रा कंडीशन है वो अभी हमारे काम की नहीं है, तो हमने जस्ट जो जरूरत की है वही कंडीशन को यहाँ पे रखा. करेक्ट? तो द थिंग विच इज रिक्वायर्ड, द कंडीशन, द proposition which is required, that propositional variable is only considered in this particular case. Therefore, it's called simplification. Okay, how about the next one? Okay, so relevant example in this particular case, कौन सा था?
Yes sir, S1 or C.
Last one, right? I will make coffee and I will watch TV. Therefore, I will make coffee, right? So this is nothing but this is corresponding to which rule? Simplification. So this is simplification. The first rule was addition. So this one is corresponding to addition, right? Okay, fine. Then the next one is conjunction. So straightforward. P is 2, Q is 2. Then we are saying P and Q is also 2, right? So simple conjunction. Okay. So it's very straightforward. So we are. I'm not discussing it in detail now. How about this one? It is called resolution. Okay. And what is the idea here? P or Q, negation P or R, and basically what is the idea here? When to apply resolution? Whenever you have one propositional variable in one statement, and in second statement you are having negation of that particular proposition variable, and then you have symbol of this disjunction, then this particular template will be there, and basically this variable is eliminated, as you can see here. So we had started with PQR, but here we are getting Q and R, and it's called resolution. And what we have already seen that this is tautology, right? Because the TF case is not possible. You can also apply other things, like you can simplify this, or you can even take the help of truth table, right? Can anyone tell me what will happen in the case of truth table? For example, let me consider the simple case. I want to show that this is tautology with the help of truth table. So how should I proceed?
We will consider only cases where P and Q is the tautology.
So basically, I am trying to, okay, so P and Q implies P. This is tautology, and I want to prove this with the help of truth table. Now what I will do, how many columns are required?
Four, sir.
P, Q, P and Q, and P and Q implies P. Okay, and now I will consider this four cases, and P and Q will be true here only. In all other cases it's false, and now P and Q implies P. So this is true, and now my hypothesis is false, then I don't care about conclusion, it will going to be true. So now as you can see, this column I am getting true for all the cases. So therefore this implication is true, therefore my conclusion is valid. Right? So similarly, in this particular case, what I need to consider, I need to in my truth table, the final column is will be corresponding to this particular compound proposition, and there I will be getting true values for all the cases, all the 8 cases, and therefore will say that this particular compound proposition is always tautology. Okay.
So we'll not be taking the cases in which S1 and S2 are true, or we'll be taking 8 of all the 4 cases in the truth table.
So if you are using truth table traditionally, then you have to consider all the 8 cases. And if you are using it intelligently, like you have just mentioned, then you need to first mention that since this statement S1 and S2 are already correct, so therefore I am considering only cases which are involving their correctness. Right?
Okay,
So,
sir.
so it depends, but if you are using only few number of, if you are using any subset of the truth table, then you need to, before writing down it, you must mention about it. Okay, why you are doing so? That's it. The explanation must be given. Okay, fine. So the next one is P is given to you, P implies Q is given to you, right? And then you are saying that Q is the conclusion, right? And it's called Modus ponens. Okay, and let's see where it appeared. Can you see it? Which one is following this particular template? Example 1 or example 2?
One, sir.
Right? 1, right? Okay. So here it's very easy, right? P is given to you, P is true, it is raining, and then you are saying if it is raining, then I will make coffee, and then you are saying therefore I will make coffee, right? So that is the idea. And again, we can verify that this particular compound proposition is tautology. Okay, and here we are concluding which is something positive, right? Q, here we are concluding Q, right? So therefore it's called modus ponens. In the second case, we are concluding negation P, right? So negation Q is given, P implies Q is given, and we know that P implies Q is equivalent to negation Q implies negation P. Therefore, we will conclude negation P. Okay, and this is called modus tollens. Right? So you need to remember these names also, because whenever you are doing simplifications, at that time in the bracket you must mention which rule you have just applied. Right? Okay, fine. So this is modus tollens, and the relevant example is which one? Can I say it's 2? Okay. Transitivity, it's also called transitivity. The idea is P implies Q and Q implies R, and then you are saying therefore P implies R. Right? We are eliminating the in between step, in between proposition, which is nothing but Q. Right? So, which is the example of this? This one. Right? P implies Q, Q implies R, therefore P implies R. Right? So transitivity. Okay, so I'm not proving it now because you already know the method. And the last one is, here we are saying P or Q is given to you and negation P is also given to you. So from this you can conclude that your final answer is nothing but Q, right? So now what I'm going to do is, in order to verify whether you have actually understood this or not, I'm going to give you some propositions and then you need to tell me whether the conclusion is correct or not with respect to this given statements. Okay. So my statement 1 is like this: negation P or negation Q and implies S and L. The statement 2 is like this: S implies T, one more propositional variable. The statement 3 is like this: negation T is also there, and I am concluding that if these 3 statements are given, then my statement P must be true, right? So this is your exercise now. So this is S1, S2, S3, and finally this is your conclusion. And you need to identify validity of this. And don't use truth table, right? I want you to use rules of this inference. तो ऐसा नहीं कि ये ट्रूथ टेबल वाला मेथड बता दिया तो हर जगह वही अप्लाई करना है और उसमें टाइम भी बहुत ज्यादा जाएगा. You can see number of variables are more here, right? P, Q, S, T, L. There are 5 variables, right? And if you follow these rules, then within 3 steps you will get your answer.
Sir, hypothesis in all rules false.
Okay, so let me make it clear. Whenever this type of question is given to you, you are supposed to use by default rules of inferences. Okay. If you don't know rules of inferences, then only you need to either go to a truth table or considering cases where, like I mentioned, TF and all those things. Those are tricks. They will work for competitive exams or MCQs. But in the exam, you are supposed to formally use rules of inferences only, right? If you don't know them and you don't want to leave the particular question, then you may use them in the worst case, right? This tricks where we are saying that this case is not possible, therefore it's always true, or we will use truth table. That those kind of things are not recommended, at least for your exams, right? For quizzes you can use, for MCQ quizzes or for competitive exams you can use this kind of tricks, but because we want to somehow appreciate this rules of inferences, and that will happen only if we use them, right? So you need to use them. Anyone has concluded P or negation P or anything? And also one more thing, इसमें ऐसा नहीं है S1, S2, S3 दिया है तो you need to start from S1 only. You can also observe something which is related, which is not related to S1, maybe S2 and S3, and then you can start with that.
सर
Yes.
सर ये सर सॉल्व हो गया सर रूल्स ऑफ इन्फ्रेंस
Okay, good.
स्टेटमेंट से मैंने स्टार्ट
Okay.
पहले तो सर टी को मैंने फॉल्स ट्रू होने के लिए सर
क्या किया आपने?
क्योंकि सर हर स्टेटमेंट सर ट्रू होना चाहिए ना सर रूल्स के अनुसार. तो पहले मैंने थर्ड स्टेटमेंट को देखा तो वो तो फॉल्स होना चाहिए, मतलब ट्रू होने के लिए टी को फॉल्स होना चाहिए सर।
अरे वही बता रहा हूँ, ये नहीं करना है आपको। ये व्हाट यू आर डूइंग हियर, यू आर अप्लाइंग ट्रिक्स कि मतलब टी एफ एफ टी वो नहीं चाहिए, जस्ट रूल्स ऑफ इन्फरेंसेस। Combine two statements and give conclusion. Use those conclusion to come. Let's say you have combined statement number 2 and 3. Let me give you some hints. Let's say I'm starting with 2 and 3 straight away. Why? Because I can see the template here. This is S implies T. S implies T is equivalent to negation T implies negation S. And what I can do? I have negation T already. So from this two, can't I conclude negation S directly? And this rule we have already seen today, right? You can notice here this one, the second one. So here I can write like this, negation T is given to me, and then negation P implies Q is nothing but S implies T in our case, but S implies T is again equivalent to negation T implies negation S, right? So even if I use S implies T, it's fine, but I can use its equivalent version also, no issues. And finally, what I can conclude, negation S, right? So this is my first rule, which I have applied. In bracket, I will write down I have applied this particular rule, modus tollens. Now, so I don't want to use anything else. I just want to use rules of inferences only, strictly. So think about it. You have this 8 rules, and these are your statements, and final conclusion is also given to you. And now you using some tricks, you have verified that conclusion is correct. So now your task is even easier, because you know that if I simplify this 3 properly with the help of rules of inferences, then I will be getting P, right? But don't misuse this information, right? So you are strictly supposed to use rules of inferences only, one more time, nothing else. Okay, so think about it. We'll discuss about its solution in the next class.